in HP hose plant, Vadipatti. So here, before entering the session, I would like to thank Professor Dr. Sheikh Mohammed for inviting me to share the insights about the industrial practices of rubber technology in a TQM approach, right? So before entering the session, I would keep the students informed that this will be definitely a useful session for all you guys, so that now in your fourth year, I think so, now you're in final year. So if you are entering a company, there will be much of challenges for you to understand the practices which are being followed in an industry. So that is one thing. So let us be very clear, and we can interact in between if it is possible. Or as Mr. Sheikh told, you can write it down and ask your queries in line with this presentation. Finally, right? So let me start the topic today. So many successful companies have been implemented this TQM approach, and this TQM is ruling all the industries today. TQM is nothing but total quality management, and as a rubber technologist, why we need TQM in an industry? So I have correlated all these things, and within a 1 hour session, what are all the important things it would be good to share you. I will collect it in this presentation, and let me explain in each and every slide for you. So the first thing is we will start with the question, right? So what is most important to be successful in a business? So I would like to hear from few students. So if you answer this, and it will be interesting to listen. So that is the one thing I have written this question here. So what is most important to be successful in a business? Anyone can answer. Please come on.
Wealth planning and time management.
Great, okay, good. What's your name?
It's Agilandeshwari.
Good, Agilandeshwari, and some more guys can answer.
To know the need of the hair and implement it properly.
Good, okay. Next.
Cost effective.
Cost effective, good, okay. Anyone from boys side?
Proper management of manpower, machine and money.
Alright, very good. Next. I want that one word which is ruling the world and ruling all the companies today.
Customer satisfaction.
Okay, fine. So how the customer will be satisfied? It's good that you told customer satisfaction, and how the customer will be satisfied.
With good quality products.
And what's your name?
Yasmin, sir.
Yasmin.
Sir.
You're Yasmin, right?
Yes, sir.
Good. Let us give an applause to this Yasmin actually. Right. So this is nothing but quality, right? Quality is simple. By providing good quality product to the customer, we can be successful in a business. So as you know, in our day-to-day life, we'll be coming across the term quality, right? So why I told when we want to become successful in a business, the important term is quality, right? Because as you know, in this total quality management, when we are into an industry, ultimately we are going to produce a product. Maybe many products would have come across. So if you take any product, there will be a start point and an end point. That start point is nothing but we are going to procure a material, raw material, right? So that raw material will be processed continuously based on the process specifications, and finally it will be converted into a rubber compound, right? So from the start to the end, right, from the raw material procurement till converting into a final product, the thing is each and every phase of production should be involved with quality, right? When you are giving continuous and total quality to the customer, then finally, as Yasmin told, the customer will be satisfied, right? So when the customer is satisfied, ultimately the business will grow. So as we know, there are other things also to be followed in an industry, but the prime requirement for a successful business is work, right? So appreciate you, Yasmin, for giving this answer. Uh, Thank you so much, Yasmin. And I would like to share a few contents here. And as I told you, I have collectively brought up some important contents for you to make you understand why we are a rubber technologist and what are all the mandatory things to be followed when we are placed in an organization, right? So first thing is TQM methodology. TQM is not so simple that we can speak it in an hour, right? So, but the thing is, what are all the industries are doing, and the important things are being collected in this presentation, and you will get a good or basic idea of what is total quality management methodology for getting into a business or when you are working in a company, how you are contributing yourself for a successful business strategy, right? And then stop me in between. If you are not able to listen me properly, please stop me. And also, I would like to tell you, நான் பேசுறது புரியல. நான் வந்து ஒரு இருப்பீங்க நிறைய பேர், நிறைய ஸ்டூடெண்ட்ஸ் இருப்பீங்க, சார் தமிழில் பேசலாமே அப்படிங்கிற மாதிரி இருந்தாலும் ப்ளீஸ் பி கோல் டு ஷேர் இட் அண்ட் ஐ வில் பி பைலிங் டெஃபினெட்லி, ரைட்? Okay. So the first thing is TQM methodology and what are all the weighing methods. And definitely, as a rubber technologist in a final year, you will know about rubber processing. What is the importance of work culture, and what are all the machineries which is importantly used in the rubber industry, and the working conditions of those machineries, and the importance of adhering to the standard operating procedures, about training and development, and I will be sharing something about SCADA and the low cost automation. And finally, that will result in zero bad. So finally, you can ask what is zero bad. So you can see it is not a definition, and but it is an objective of a total quality management, right? So TQM is an effort to create the right environment for achieving the total quality by involving all the employees of an organization through structured process approach, where we should work consistently to meet the ever changing and ever increasing expectations of the customer. So this is a consolidated objective of the total quality management, right? So in this definition, I have highlighted a few words. It means that the scope of this total quality management is to create a right environment where you are going to work. How we are going to create the right environment? By involving yourself and the fellow mates who are working with you. And how you are going to involve your employees? We have to create a structured process approach in whatever you are doing in your industry, by consistently meet the changing and increasing expectations of the customers, right? So when you want to become successful in your business, then we have to change ourselves in every 6 months or 1 year. So change is nothing but you have to improve your process. You have to ensure whether your process is in the right path for giving the good quality. So as to total quality, this total quality management will be helpful for you, right? So how we are going to implement this TQM? The people who are working in an organization should be made competent and capable to achieve the objectives of TQM through improving the processes which you are going to work in, and finally by improving the final product as well as the services. So this overall objective of the quality management is to start from raw material procurement, convert into a final product, ensure all the processes are in line with your standards, and finally when the quality is accepted by the customer, right? Ultimately, if you are giving a good quality product, then definitely customer will be satisfied. So that is what I am coming to say here. And here, these are all the steps to implement TQM. This I have consolidated, and I didn't explain it one by one in my subsequent slides. But Please have an understanding of what are all the things which is displayed here. Please write up and ask about these steps and how to implement finally in the query session, right? So it starts from basic 5 years, right? So everyone knows 5 years maybe. If you have doubt, I will explain in the query session, right? So 5 years starts with, many people will understand the 5 years starts with cleaning, right? See, when you start cleaning a machine, right? Why I am repeatedly speaking about machine and shop floor and process and this quality importance is, as we are all rubber technologists, and since rubber is only a material, rubber is a chemistry. I don't want to get into the chemistry part. The rubber is a chemistry, and how the chemistry will work properly. So that is one thing we have to understand. When we want the rubber chemistry to work properly, then definitely we have to establish and maintain the process in a robust manner. So that when you standardize the process, then definitely the chemistry of rubber will work accordingly. So that is one thing you need to understand here. And why basic 5 years? As I told, 5 years starts from cleaning. As everyone knows, one S is sort, 2S is set in order, 3S is shine, 4S is standardize, and 5S is sustain. So this is some big part where if you are interested in future, I can take another lecture also. So this is basic 5 years. So when you start with cleaning your machine, right? Cleaning your machine, cleaning your workplace, and whatever inside the shop. When you start cleaning up a machine, then what you will find? So you will be finding the abnormalities in the machine, right? When you find the abnormalities, like if you are going to work in a rural domain, either maybe a Banbury or a meter or internet or whatsoever it may be. So if you are working in Banbury and you are starting up with cleaning each and every day morning when you are entering the shop door, if you start with cleaning, abnormalities will be raised, right? So when you see the abnormality and when you start addressing the abnormality, addressing in the sense, in a small example I can say, in a Banbury, right? In a Banbury, you find there is a leakage. We are going to process now, in our rubber compound is processed in a Banbury mixer or either maybe intermix. So when you start processing, there may be a leakage of hydraulic oil or some oils in the Banbury. So if that is an abnormality, if you start cleaning, then once again the oil will come out, right? So if there is the continuous leakage of oil, definitely it is a abnormality and it should be fixed appropriately, so that the corrective action is taken for that abnormality, right? So identify all the abnormalities in a machine, fix it properly so that there should be a zero abnormality. So when you start with cleaning, you are finding out the abnormality, you are fixing it. Then if you fix it automatically, then we will ensure that the leakage of oil will not be getting inside the Banbury while we are processing. So that first thing, we are ensuring the quality. I am giving a basic example, right? So when this is ensured, the compound which you are going to mix in the Banbury or any other machines will come out in a standardized manner. That is as per the requirement, right? So this compound is the base part of any rubber compound, right? When you are designing a compound, you are creating or mixing a compound. That compound is processed to convert into as a final product. So if you start the process with cleaning, then you can ensure the quality. When the quality is improved, then ultimately, as someone told, the customer will be satisfied, and the customer, if satisfied, the business will be developed, right? When you start a cleaning process daily, it reaches with the customer satisfaction and finally the business growth. So that is the importance of 5 years. And as I told, if I have an opportunity in the future, I can explain more about 5 years, right? So what is mainly required for all these points is the total employee involvement. As I told already, we are all an employee of a company, means we have to involve, we have to work along with the people together. As if you are an example at shop floor, that if you go and start cleaning your machine, then automatically your subordinates and your homemakes will be listening to you, and they will also start cleaning the machine in between, right? So that is one thing. So when you start cleaning a machine, then finally it will result in the business growth. And the second one is unlearn undesirable personal behavior. See, the next 2 points are like we have to ensure the practices at work are good, means as per the requirement. There are some policies given by the management, and we know as a matured person, we know what are all to be done and what not to be done, right? So when this undesirable personal behavior is being done or being monitored by your superiors at shop floor, then definitely you have to stop it and unlearn it. So that we have to learn, unlearn, and relearn. So these three are the mantras, as you know, wherever you go, we are learning good things, unlearn which is not required and which is not required today, and relearn something, right? So these three are the important. The next one is unlearn undesirable work practices, which leads to the bad environment, as I told. And the fourth one is the suggestion scheme. See, these are all the steps where the TQM focuses on. Suggestion scheme is nothing but if you are working in a shop floor and along with your operators or roommates, then as I told, if you find some abnormality, you have to give a solution for it with a small suggestion. Like uh, as I told you, there is oil leakage, right? So there is oil leakage in the banbury. You will be cleaning it, you will be identifying the abnormality, and you are going to fix it. How we are going to fix it is you will be identified that in the hydraulic unit where the oil is coming from, will have a O-ring, for example, rubber O-ring. So when the rubber O-ring got damaged, then definitely oil will come out. So if you want to fix the abnormality, replace the rubber O-ring. So that is a suggestion. That is what this employee suggestion scheme explains. And the next one is certified operator, right? So as I am repeatedly telling about the total employee involvement, as we are all an employee, the operators will be working at the shop floor in your industry. So the operator should be capable to understand what is TQM, what is basic bias, and how they are going to contribute themselves for unlearning the bad work practices and undesirable personal behavior. So operators should be trained in each and every requirement of the TQM, and we have to certify them so as to ensure that we have out of 100 we have some 90 or 95 certified operators, so that the business will be successful, right? If each and every person, every operator industry is working in a different path, then definitely the results will not be common. Results will be diversified, right? That is what the certified operator tells. And there must be facilities. When you are going in an industry, there are some certain facilities to be followed. So those are called must be facilities. For example, if yeah, I will keep the example as Banbury only, right? If you are going to a Banbury and you are giving a schedule, or you have developed some compound or something else, right? In any function, you can say. If I am in a production, if I am a production guy and going to a Banbury, and I'm giving a schedule, some production schedule, I'm going to go to operator. So if that is the case, the operator should feel comfortable to work for the 8 hours in a shift, right? So if he wants to be comfortable, there are some certain facilities, right? Certain facilities for it is a basic example, right? He should need a fan, right? Some fan he need. Then he needs some water. He needs some lighting arrangements, and some ventilation should be there. So these are all the basic requirements. Like this, what are all the requirements in a shop floor you need to understand, and these facilities to be given to the particular operator. So when all these facilities are given, the operator will feel satisfied so as to focus on the process, and if it is an operator dependent process, then ultimately he want to get satisfied, right? So when he is satisfied, then definitely results will be better. So that is what this must be facilities tell. And the next one is my mission concept. My mission concept, as I told in the basic, so yes, we have to start from cleaning, finding out the abnormality. There are some tags system is there. So it will start from step 0 to step 3. Right. It is also, as I told, we can't cover all those things in TQM. Just you want to understand what is the my mission concept. Cleaning, raising the abnormality, fixing the abnormality, run the machine, what product to be produced in that machine, just produce it, and based on the standard specification, just cross check the product, and if the product is still having the range is more, that is the variation is more, means then once again look for abnormality, correct it, fix the issue, then recheck your product, and finally at a point of time you will get a good product quality. So if that is the case, then you can prove that your machine is running in good conditions, right? With this, what are all the activities to be done in a machine will be completed. So we have to identify all the abnormalities in your shop floor at every machine and fix it accordingly so that each and every machine will be running as per the process required. So that in detail will tell about this my mission concept. The next one is parts handling and logistics, right? So what are all the products you are handling in between? As I told, started from raw material procurement till the final product conversion. So in between, you will be handling the products at each stage, right? So that those sub inventories will be passed to the final inventory. So if that is the case, you have to handle the product appropriately, ensuring the quality. For example, if you are producing a O-ring, right? So producing a O-ring means O-ring, if the dimension of the O-ring is the cross section of the O-ring is like it is only zero point 0.4, zero point 0.3 or something like that. Zero point 0.4 means mm, right? I'm telling in mm. 0.3 or 0.4 mm means it is very precise so that we have to handle it appropriately to convert it into as a final product, right? Means when it is getting into an assembly, we have to handle it properly. So that is what this parts handling and logistics tell. Means they will say the three terms in it. 3C they will tell. They will tell. 3C is first C is clean, right? Contact free and count free. They will say clean, contact free and count free. So when you are carrying a product from place to place, it should have been you should ensure that it is clean, it is not in contact with each other, and we should be able to count it freely, right? So those three things, this parts handling and logistics type. And it's low cost automation. Now everywhere there is a competition in all the industries, right? So what is the competition? We have to go for digitalization. Digitalization in the sense all the process to be monitored through online and the manpower. They usually the people will say we have to reduce the cost, right? And the manufacturing cost and final cost we need to reduce. That is the case in shop floor as a shop floor guy or in if you are in a development or if you are having some lab machineries. Finally, what you have to do, you have to think about automation projects, low cost automation projects, so that this low cost automation will be useful for you to reduce the cost. So that is what this low cost automation is. And ritual part screening. Ritual part screening is nothing but every next process is your customer, right? So if you are starting from mixing, you are into a like as I told, I am into a hose extrusion, hose industry. In hose, the initial process is the weighing of all the chemicals. Then next process is mixing the compound, and the next process is go for extrusion, means giving a shape to the rubber ball. So these are the three processes. My customer is means I am working in a chemical weighing area, chemical weighing process. If I am working in chemical weighing, my next customer is the mixing process. For mixing process, the next customer is the extrusion. For extrusion, the subsequent process will be the customer, right? So if you have this concept in mind, then you should not think about your final customer, right? Final customer means it is our main customer who are going to give us an order to complete it and supply as per the quality requirements and standards on time. So this is the requirement. If we think and work inside an organization as the next process is the customer, then definitely you will get involved yourself more and your people also to focus on the quality, focus on the process, and all the errors will be avoided under particular area, particular process itself. So that is what ritual part screening does, right? So the main thing, as I told you, is the total employee involvement. Total employee involvement is completed through these four this abbreviation of the supervisory improvement team. SIT is supervisory improvement team. CFT is cross functional team. QCC is quality control circle, and TFT is task force team. Right. So the main objective and the prime focus of these teams will be addressing the issues which you are facing in the shop floor. It may be process issues or product quality issues, anything. So we have to form a team, and that team will be having a proper agenda of the project, and there will be some particular timeline for completing the project, and within the timeline we have to fix all the issues. So I can speak about SIT for an hour. So just you make you to understand what are all these four terms, and if we involve all our people with all these four terms, then definitely 100% of the 99.9, say 99.9% of the quality issues can be arrested when you are employing your involving your employees very focused, right? This is what total employee involvement is. And finally, this is standardization. There are, as I told, there are so many practices which are to be followed at shop floor. And finally, when we are arriving with the solution, then definitely there will be a background of the parameters and what are all the process parameters to be followed at each stage, and what are all the checklists we have prepared, what are all the audits we have done, and what are all the FMEA they will tell how many FMEAs have been raised and how those are all fixed. So there we have to create a standard for all these and we have to follow it, right? So we have to convert it as a culture, right? So culture, as I told, now I'm using the word culture. Every industry today needs a cultural transformation, right? So cultural transformation can be done based on certain disciplines which we follow at the shop floor, right? So this is one of the discipline. TQM is one of the discipline which will definitely bring a cultural transformation to become a successful industry, successful business, right? So daily work management. So these are all the important terms I am sharing you. This daily work management is nothing but when I am employed in an organization, right? When I am employed in an organization, I will be having a particular activity prioritized for the day, right? So what are all the activities I should prioritize accordingly? Those activities it need to be recorded and monitored, right, day to day. So when if I am having a responsibility and that responsibility is completed day to day, then definitely error will not be taken to the next day, right? So that is what this daily work management is. So you have to display your schedule. While you are inside a company, you have to display a schedule. And as a overall, I can tell you, daily work management focuses on 5M, right? The main thing is man, machine, method, material, and measurement, right? So these 5 M's we have to focus upon. So when we are focusing upon this 5M, then definitely you can improve your productivity, then your quality, then you can do cost savings. Then what else we can do? Delivery, you can give on-time delivery to the customer product, as well as you can focus on safety also. Safety is also a prime requirement for us to work in a company, right? So these all the things which is coming inside daily work management. And the next one is policy management. Policy management and human resource development will be taken care by the top management people, where when you are fixing a policy, when you are defining a policy, what are to be done and what not to be done by the employees. This will be clearly defined, and we have to adhere to it also. So as a consolidated thing, we can be a successful person in our career, as well as we can ensure that our business is growing in a hierarchical manner. So, as I told, this is a vast topic. I can explain more about it. Just I wanted to make you understand this is a basic requirement of a TQM discipline. When this TQM discipline is implemented at the shop floor, you can able to stay successful in your career, right? So here, whether if you know or don't know, just I would like to share from the basics, little basics, and then I get into the small examples, and I would have shared some few photographs of the things which I have told in the previous time, right? So the weighing methods, as you know, this is a conventional weighing. Initially here, this is a conventional weighing where an operator is using a scoop for weighing a chemical, right? So as we know, all the chemicals are brought together and mixed together to form a finished compound, right? So this practice should not be done as per the TQM, because when you start weighing it manually using such scoops, definitely it completely depends on the manual interruption, right? Frequently the man will be interrupted in between. So when we interrupt, the man is interrupting in between, and the process depends on him. Then definitely what happens, there will be error. Means there is a possibility for wrong weight. Means wrong chemical can be weighed, as well as the weight will not be maintained properly. So this is a manual weighing method which is not recommended. And here you can see it is an enclosed cabinet. Here you can see the batch weighing system, which is semi-automated, where in these containers, all those chemicals which you want will be filled in, right? So almost some 40 containers are there, right? In 40 containers, in the sense 40 chemicals can be loaded inside. So these containers will be operated based on the HMI. HMI is nothing but human machine interface, which is they will be using a small PLC for automating it. Just you understand. I will explain in detail later, right? So when you are using such a semi-automated batch weighing method, you can ensure the right chemical is being taken for your compound. Then second thing is right quantity, right chemical and right quantity is ensured. No? Then definitely your compound design will follow the intended results, right? When you are designing a compound, as your R&D guy, you are going to design a formulate a compound. You will be formulating it in a PHR, right? Parts per 100 as you very well. So if you are formulating it in a PHR, then definitely that PHR should be going inside the Banbury or any mixers for converting into a final compound. If you are weighing wrong compound as well as wrong weight, definitely your intended compound quality will be fail. It will be an error. It will be deteriorated. Right. So that is one thing. So you have to think about implementing the batch weighing system, a complete fully automated or semi-automated system at your workplace. Right. So here this is automated mixing solutions. Right. So nowadays, as a rubber technologist, we know, as I told, we need to eliminate our manual errors one by one. So when we are completely eliminating all the manual errors, then definitely our process will be stringent. It will be a robust process. So when we want to take your process in a robust manner, then definitely your process should be automated. So that is the final thing. So when we automate all the mixing, right, starting from the chemical weighing as well as till the mixing process, then definitely we will ensure that there will not be any single error when the standard specifications are followed by process. This is provided, I am telling you. When you follow all the specifications as per this automated solution, then definitely your compound will come out in a perfect manner, right? So this, as you know, we know better about, you know better about rural mill. You are using in your laboratory also. So I don't want to explain in detail about what is intensive and dispersive mixing. Just I wanted to show the whole nomenclature, right? So as we know, there is a fill factor. Fill factor is also one of the important thing for maintaining the compound quality. If your machine is having a machine is having a capacity, right? So you have to understand the capacity of a machine made in Banbury in terms of Guru. Right? So if you are understanding the capacity, then the weight, that is your compound, should be loaded appropriately so that the dispersion will be better. As there are three phases of mixing. In incorporation, distribution, and dispersion. So you would have been aware about it. So these all three phases will be in a maximum positive manner when you maintain the fill factor. If the fill factor is not maintained, then all your three will be failed, right? So this is one thing. So you have to just, it is a role nomenclature. And here you can see an example of Banbury mixer and integrated mixing mill. So this is the Banbury mixer, typical view of Banbury mixer, where the operator will stand here and he will be loading all the rubbers, chemicals, process oils, fillers, cooling agents, accelerators, activators, what all the ingredients you are going to use, all those things the operator will be adding here. So this is a typical view, and here you can see this is a RAM, right? This is a RAM where when it is, this is a hopper door. This is a hopper door. When the hopper door is open, then all the rubber and chemical oils, all the things are filled. We will be following a sequence of mixing. So when the mixing sequence is appropriately followed, then definitely the mixing will be good. So this is a typical view of a 40-liter two-wing rotor design for Banbury. Right. So here, why I am telling this as integrated Banbury, here you can see a chute. This chute is integrated to this Banbury. So when you finish your mixing process, that will be dumped on this mill. This is a door opener. So when it is dumped on a mill, then here there will be a standard operating procedure for ensuring the good dispersion of the mill, right? So this is a 22 by 60 integrated mixing, just for review. So this is a typical capacity of mixing mill, mixers and extruders, and just I wanted to show you that's all. So no need to spend more on this slide. So it shows only the if you are going to a F50 primary mixer. See here, if you are going to procure a 50 primary mixer, then the chamber volume will be this, and the batch weight will be this, and what is the maximum speed we can RPM of the rotor we can follow, and torque and motor and gearbox and all those data will be given here. Right? So here, Sheikh Mohammed, am I audible?
Yes, yes, you are audible, audible. You can go.
Audible, right?
Yes, yes.
Right. Okay, fine. Students, from the student side, am I audible and am I clear? Do you want to change my language or something like if you wish? From student side.
No, sir, it's about you.
Right, am I audible? Am I clear? ஏதோ புரியலையா நான் பேசுறது புரியல அது மாதிரி ரொம்ப அது மாதிரி இருக்குன்னு சொல்லிடுங்க தமிழ்லே பேசிக்கலாமா?
Senthil, go ahead with English, no issues, please.
Fine. Thank you. So this is a cultural transformation, right? So as I told the word culture, this is a shop floor, typical shop floor. This is a view of a typical rubber industry, right? So at the end here, we will be having a mixing area, right? So here there is a raw material storage area. The raw material will be weighed and it will come here to a weighing process, and here nearby we have mixing process, and all those extrusion and subsequent process will be there. When a customer is entering a shop floor, right, as the objective of the session is to finally go for business growth, and that business growth starts from implementing this total quality management process, right? So if you see this shop floor, this is a gangway where the people can visit. So there you can see there is a positivity here because all the machines have been arranged. There is a gangway mark here, and here if you are doing this plastic container, plastic crates, there is a marking done here, and here you can see there is a board, right? There is a board in the sense in this board it will be written as this particular area, and these are all the machines are here. So there is identification, right? So when you enter a shop floor, the customer should feel that if you are based on the perspective of the customer, they will think that we are producing the good quality product here. So that is ultimate requirement of this total quality management. So when you want to go for this cultural transformation, these all things to be done at shop floor. So this is a jogging track. This is a new term maybe for you. This is jogging track. So why I am telling it here is, see, here you can see there are some trash is kept here, right? There are some waste kept here, and when a customer is entering, you should initially take the customer, you should have the guts to take the customer nearby the walls. If there is a wall, and if you are taking the customer in this way, then the customer will continuously have a view on the shop floor to the all four corners, right? So that they will ensure that we are maintaining the shop floor properly, and we are not dumping anything like the waste raw material or waste the scorched batches or whatsoever it may be at the nearby the wall, right? எப்படின்னா வந்து நம்ம வீட்டில் வந்துட்டு என்ன பண்ணுவாங்கன்னா நியர்பை த வால் they will be placing something which is not required today but it may be required tomorrow, right? So அப்படி இருந்துச்சு அப்படின்னா you should not practice that culture inside the shop. When you start practicing it, then you will be little lazy and you will not see that tomorrow. Then it will be stagnant here in the same place. So that practice should not be done. So for that there is a term in TQM called jogging track, where you should mark some 600 mm from the wall so as to maintain the cleanliness in the shop floor. So I told about this low cost automation initially when I am discussing about the steps in the TQM, right? So here there is a low cost automation where you can see here there is an arrangement of a pneumatic cylinder here. Pneumatic cylinder is there, and it is a small setup where no need much of investment here. So as a shop floor person, you can think something differently, and before what the people will do, this is extrusion line, right? In this extrusion line, the hose or tubes, whatever it is extruded, before the people will be using some scissors or knife to cut it manually to ensure the length of that particular hose, right? So here what they are doing, they are using a cylinder with a small investment, maybe less than 5,000, less than 10,000, right? So they have taken some internal available accessories and they have done a small improvement. And in this, we can ensure the uniform length of the hose cut. So this is one thing. So this is called the low cost automation. This termed as auto cutting of extruded tubes. So this is one thing I would like to share. And here is another example of low cost automation. When there is some metal impregnated rubber product, right? So there is a rubber component along with the metal. Here you can see there is a metal tube which should be passed in the extruder line. Manually, it will be pushed by an operator inside the extruder line. And when you are pushing it inside the extruder line, once again it depends on man. So the man will not push it with the even load, right? When your the load is varied, when your force of pushing is varying, then definitely when it is coated along with the rubber compound, there will be a variation in the thickness, right? So these things we need to avoid. And here what we have done, here you can load all the metal tubes, and there is a systematic PLC arrangement done to ensure each and every tube will be pushed along with the pneumatic cylinder inside the head of the extruder, so as to maintain the uniform wall thickness of the rubber component and along with the metal. This is once again an example of cultural transformation where this is dumped, it is in a shop floor where it is dumped, where there is nothing but hose. This hose is being packed in this gunny bags and it is being identified, it is thrown in a particular area. But it will be, as I told, in the next process, you should think as a customer, right? When you think the next process as the customer, and you have to handle the product appropriately. So I told about this parts handling and logistics. Okay, there is parts handling and logistics, and in that we will be following a 3C concept. If you follow the 3C concept, this is the basic requirement where we are using plastic crates and it is being identified so as if you take the crate out, it will be countable, it will be clean, and when a customer is visiting, they will have a positive perspective. That's good. Actually, this rubber tube, the first picture is corrupted, sorry for it. And this is also an example of container. This is what a 3C container is. This is what a 3C container is. Here, before, there will be a trolley which is being used, and all the rubber components will be stacked in a horizontal manner, one over another. One over another in the sense, the first layer of the rubber components will be overloaded, so as there may be a possibility of internal stresses and a failure of the component in the application. So here in this TQM concept, it is recommended to use 3C container, so as all the tubes are produced automatically. So this is a container which is designed for accommodating 150 tubes, right? So if you maintain cleanliness in this container, then definitely when you are taking this trolley to your next area, then you can count, alright, here we are having 150 tubes and the trolley is also clean, and as well as each and every tubes are not in contact. In such a way, you have to design your 3C container for handling your parts in between. Many rubber components may not require this container. It depends on the requirement of the product, right? And here it is VSOP and OPL. VSOP is nothing but Visual Standard Operating Procedure, and OPL is 1 point lesson. So this is the this can be done immediately when you are finding an abnormality at shop floor, right? So many people see, as we know, we are all management staffs. If you are going into industry, you will be handling so much of operators, right? Workmen, you will be going to handle so much of workmen. And if you are going to work with the operator workman, then that person should know about the process, and he should be daily monitoring the process, so that he will understand at what stage of process what to be done, right? So here is a typical example of VSOP where the total process completely split up in some 11 stages, and when you are displaying it in the work area nearby your process, the operator will be regularly seeing it, and it will be memorized for him, so that he will train himself as he will not do any error in the process. So this is an example of VSOP. The total operations is split and explained at each stage. So this is a Visual Standard Operating Procedure. and here it is a 1 point lesson. 1 point lesson we can use it for all over the shop floor requirements. For example, here I am giving it for safety point of view. See, this is an operator. When he is going to work in a process, so he need to wear all these personal protective equipments, right? They will term it as PPE. So we have to wear this cap, we wear this earplug and the dust mask and all this apron and gloves he should wear. So these are all the do's and don'ts of the particular process area, where you can use it for a quality requirement also. If you are going to an industry, once again, if you are finding an abnormality and you found that that is because of an operator mishandling, right? So what issues he have done in the process, what issues he has done, that to be captured, and don'ts you have to create, right? Don'ts means the operator where he have done mistake, that mistakes to be captured, and do's, you know what to be done. So that do's to be captured, once again it can be converted into as an image, and you can display it in the particular process area. If you are displaying it, then once again, as I told in the VSOP, you are educating the operator continuously, and the operator will have a good idea of what all to be done and what not to be done in the process. So these are all the few examples of TQM to be addressed at the shop floor, so as to involve all the employees for common objective of the management. Right. This is a typical VSOP for autoclave operation, and here this is a complete curing process, right? So there is a drum along with the rubber component which is sent inside for curing, and each and every stage what all to be done. We have to open the valve, and if it is autoclave, then the medium of curing is steam, right? So steam means we have to open the valve, we have to switch on the power, and we have to follow certain procedures. We have to take the battery pallets on this area, and we have to start the PLC. So all these things will be covered here. When you are, once again, you are displaying this at, for example, at a curing process, then definitely the method of handling that particular process will be standardized, right? So these are all the example of visual standard operating procedure. And as a shop floor person, as a development person, you can use this, as I told, LC, low cost automation. So this is a image process rubber product, right? It's like a belt actually. So I am sending, for example, this there are, in the first image you can see there are three belts. Okay, these three belts are packed and sent to a customer, for example, right? If there are opportunities, since if it is not automated, then definitely you will use some manpower for packing it together, right? So we have to ensure whether this three is exactly packed and sent to the customer. So we have implemented some low cost automation where we are using some software to process the image, right? So process the image. So this is the original image, and we would have fed what are the master sample in that particular program, right? So when the master sample is fed in that particular software, then it will correlate between the master and the actual sample and tell whether the processed sample is okay or not. So ultimately this component to be sent to the customer. This is not recommended, right? If you send these three, then they will say, the customer will receive it and say there is a short supply. I need 4, but you have sent only 3. So we have to understand the importance of this, and as a shop floor based person, once again, we need to think along with the team. We need to learn so many things as a shop floor person, and do some improvements in house with the available facility, like this image processing system, and ensure the final product quality. So that is what this image processing tells in a part of low cost automation. So here the storage conditions, as I told, in a shop floor there is a raw material storage area, either it be rubber or all other chemicals or oils. So here you can see there is a conditioned storage. There is an AC conditioned storage. It is an enclosed area where they are using proper racking arrangements to store all your chemicals and rubber, so as we can ensure. See, raw materials. We don't know as a shop floor person. We will be procuring the raw material. Either it will be imported or it will be localized. So many suppliers will be there, right? So since we have the checking parameters for accepting the material, we have to handle the material properly, store them properly. So it is a basic requirement. When your material is stored appropriately with conditioned storage, then definitely the deterioration will not happen in your product. So that is one. And here, this is SCADA, right? It is a process control through SCADA, right? They will also SCADA and data capturing is different, but SCADA is nothing but you will be having a control altogether in your process. SCADA, the abbreviation of SCADA is supervisory control and data acquisition, right? So that is called SCADA. It is a system of software and hardware elements that allows our industry to control the process locally or at a remote location. So that is one thing. You may ask, sir, idella enna sir? There are so many circuits are there. I don't know what is happening here. No? So you can understand like this. Here, it is you can consider this as a curing process, right? So this is a curing process. Up curing la, curing la, I have done a product, I have mixed a compound and I have extruded or I have molded something, right? So sorry, if it is an autoclave, we are going to mold only at curing autoclave area. So this autoclave SCADA tells what are all the process parameters to be followed. One thing, what is the temperature of the batch to maintain, and what is the time, curing time, right? And when we are going to give the steam inside, what should be the out time of that particular process, and whether it is a step curing and what temperature to be followed, how much time to be given for raising the steam. So many things are there inside SCADA. So when we do it manually, then once again there is an error continuously. Then if you are implementing this SCADA system, it is a small PLC control system. When you are implementing a SCADA, then definitely once again your curing will be appropriately as per the right. So curing is an important thing where your product is converted into rubber, right? Before that, what are all the design and formula you have given to your software guide, when it is cured properly, then definitely the product will be as per the intended requirement. So that is one thing. So you have to ultimately give focus on curing also, right? Then here, as I told, this is a PLC controlled SCADA process where there is a vulcanization, and the problem here is there is no data capturing system before for the rubber component where the process could not be ensured for right quality, right? So, and the action taken is we have implemented SCADA or some data capturing system, and finally, when the curing is done properly, if you are facing some issue with the customer will say we are facing some crack issues in your rubber component, right? There may be some other factors also, but you should have a grip with you, like you're having evidence of data captured, right, in your SCADA or data capturing system. So here you can see there is a temperature 138.9, and here is also here is a temperature. It means that there are some 3 to 4 different autoclaves for organization, and what are all the temperatures being followed. So this can be monitored in online, and it can also be recorded with your recorded as well evidence, right? So when there is a customer complaint, raising a complaint, what we will do, we will understand the complaint, and based on the complaint, we will know, okay, it is a crack, right? If it is a crack means first thing what will come to our mind is whether the product is undercured or overcured, right? So we will think. So when it is overcured, then once again there may be an increase in the temperature. There will be some manual error done by the operator. The steam will not be got into the autoclave properly or on time, or else the curing time is little more because there is a malfunction in the machine. So many issues are there at the process, right? So when you are creating a robust process like implementing this SCADA system, then definitely your process will become stable. These are all the, as I told, there are the temperature for all the autoclaves, and here it is a curing pattern that you can monitor online. So the process starts here, and from here the curing starts. So there is a step here, and here, as I told you, if you are going for a step curing, right, here it is up to 130, for example, 130 degrees centigrade. We have to maintain some 20 or half an hour of curing time. Then remaining, you have to then go for 150. So 150 means then the steam will be raising for next 5 to 10 minutes. Then it will be some 20 minutes to be maintained at 150. So there is a curing pattern you can monitor in your day-to-day shop floor, and finally, based on this profile, you can understand how your curing is done. So this is one thing. Right. So I will complete in few minutes. And this is D-mic. D-mic is nothing but it is a part of Six Sigma, right? Six Sigma is a vast area, and D-mic is nothing but define. There are some 5 phases, right? So this is called define, measure, analyze, improve, and control. So here there is a typical example given. We have received a customer complaint. So this is a rubber component, receive a customer complaint, and we are going to analyze it, right? When we are going to analyze, we will be using some YY methods, right? YY methods will be using, and we will be asking, there is an air pocket on the product surface, and there is an air pocket, then definitely why the air pocket has come, and the final root cause of the air pocket at customer complaint is unavailability of the vacuum pressure testing facility at the process. So that is one thing. And the next analysis tell there is unavailability of cooler unit at your extrusion process. So this analysis phase, and you have to define where the customer complaint has come, and what is the product, and what is your part name, how much quantity your customer told it has defective, and what description they have given for the problem, and who is the customer. And in this improve phase, measure phase, and control phase, what are all the actions taken by you should be recorded. So this is a one-page summary of a DMIC report. So as to address a complaint, either it may be a customer complaint, either it may be a shop floor process issue, or any rejections you have done at the shop floor. All those things to be monitored. Maybe it can. There are some other tools also, but this is also important, right? So as I told, we have done at extrusion process. There is indication lamps given. This is meant for monitoring the temperature of the zones of the extruder, right? There are some 4 to 5 zones, depends on the extruder. So there are 4 zones. These 3 zones are running at a intended temperature. Means, for example, 55 degree, you say. If the requirement is 55 degree and the tolerance level is plus or minus 2, for example, right? So we have to maintain 48 to 53 to 57. That is the case. Then this alarm indication will tell, no, there is some issue, please go and address, as I am indicating it as red. So go and do something in the machine and correct it immediately. So you will be ensuring the process. These are all the small improvements you can do it in your process. And this is a CFT extruder, cross cold feed vent extruder. And here there is a tube extruder, and here there is a monitoring system. So the process says here the temperature should be only 50 degree, right? So if it is 50 here, you can say there is 50 degree. So when it is beyond the limit, then definitely we have to go and correct the process. So that is the process monitoring system. So here there is an autoclave where it is meant for curing. Here also it is green, where most of the people, what they will do, when the curing cycle is not started, they will push your rubber components awaiting curing and close the door. So in the previous curing cycle, the temperature will not be brought down completely. So as the temperature will be up to some 60 or 70 degree, for example, right? So if without starting the cycle, if you are pushing the load, the rubber component, and closing the door, then definitely the curing starts slowly. So that is not a good practice. So the thing is, if this green lamp is indicating, then definitely your process has started. So this is a small indication and improvement you can do. You can do it in your process. This is a problem solving methodology. This is also a vast area. I can explain so many things about problem till conclusion. But this is the most successful tool for coming a conclusion to the problem. Right? There is a problem. Right? If there is a problem, you have to observe what are all the issues generated because of the problem, and what are all the things which can be affected because of the process variation. All the data to be observed. Then you have to analyze. Analyze, as I told, the YY analysis in the previous slide, in the DMIC area, right? So using YY analysis, you have to analyze, find out the root cause, and for that root cause of the problem, you have to take the countermeasure. What is the countermeasure? Like as I told, I have implemented this indication system. Before that, the operator will be closing the autoclave door, and he will not start the curing. whenever the load is given inside the autoclave and the curing is started, then definitely this green lamp will indicate, otherwise red lamp will indicate. So this is an alert given to the operator. It is a kind of action, right? So when you are taking an action, you have to check the side effects of that process. So that will come in check phase. Then finally, as I told, all the checklists and whatever standards you have to update it and standardize the process. And finally, you have to come up with the result. So this is a step-by-step tool of addressing a problem. Till this, it is clear, everyone? Am I audible, Mr. Sheikh?
Yes, Senthil, yes, Senthil.
Right, okay. So if students, if you are having any doubt, please have a record of it, write it up in your diary, just we can discuss it. We are running out of time actually. Right, this is Pareto chart, right? As I told, there are 7 stages before, right? There are 7 stages. In these 7 stages, we are going to identify a problem, right? If you are going to identify a problem, this is a Pareto chart. Pareto chart is nothing but, Pareto is the inventor of this chart actually. They will term it as 80-20 rule. So in most of the cases in industry, they will apply this 80-20 rule. So this is 80-20. Why I have circled it here is, many problems like 80% of your process problems or industry problems is only because of 20% of the causes, right? அதாவது உங்கள் ஷாப் ஃப்ளோரில் ஒரு 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 ப்ராப்ளம் இருக்குது அப்படின்னா, there are so many problems, right? அவ்வளோ ப்ராப்ளம்க்கும் there are only 20% of the causes. That will say, this Pareto chart will say that, right? So for example, here there is a dimensional variation, there is operation missing, there is some coating issues, casting, so many defects are there. So out of all those defects, the first 2 will tell these 2 can be addressed for killing the 80% of the problems. அப்படிங்கிறத இந்த Pareto chart சொல்லுது. So எல்லா உங்கள் ஷாப்பில் இருக்க எல்லா ப்ராப்ளம்ஸையும் வந்துட்டு you have to include it in this Pareto chart, and you should first understand, என்னோட ப்ராசஸில் வந்துட்டு மொத்தம் வந்து இந்த 80%க்கும் இந்த 20% ப்ராசஸ் தான் வந்து ஒரு மெயினாக கான்ட்ரிபியூட் பண்ணுது. So when I am addressing these 2 causes alone, this 20% of the causes alone, I can solve my 80% of the problem. That's the Pareto chart. Observation phase la you can use the 5 senses, right? When you are seeing a problem, then see, when you are ending up with the problem, இது 5 நீங்க யூஸ் பண்ணணும். Like we have to see it, how the problem has occurred. We have to listen it. Listen, here it means, for example, as I told, leakage from the Banbury you can see. If you are going to hear something when running the Banbury, the rotor alignment will be mismatched and your RAM will not work properly. So many things are there. So if that is the geometrical variation is there, then it will result with the vibration that you can hear. Then the smell, like there is a short supply in your electrical issues, then there will be a short supply and the cable will start burning and smoke will generate. That you can smell. And you can touch and see. Once again, vibration you can touch and see, and feel also. You can use all these senses to observe a problem in the observation phase. In analysis phase, as I told, YY analysis. So before going to one YY analysis, as I told, there are 6 M's. You can use it here, right? What is that? One is man, machine, method, material handling, and measurement. ஸோ உங்களுடைய ப்ராப்ளம் நீங்கள் ஒரு இஷ்யூன்னு சொல்கிறாங்க, யூ எண்டட் அப் வித் த ப்ராப்ளம். அந்த ப்ராப்ளம் வந்து மேனால் என்ன வந்துச்சு, ஸோ மேனால் இருந்துச்சுன்னா அதோட காசு என்ன பார்த்தோன்னா வந்து மார்னிங் வந்து வி ஹேவ் டு கிளீன் த மிஷின், he has not cleaned it properly, so this leakage is not visible, so the machine is not corrected. So man பண்ணியிருந்தா அந்த ப்ராப்ளம் அரெஸ்ட் ஆயிருக்கும். ஸோ அந்த மாதிரி யூ ஹேவ் டு ஐடென்டிஃபை what are all the causes because of machine, what causes because of method, material handling, measurement, and material, and so many things you have to identify, right? So இது எல்லாத்தையும் நீங்கள் கண்டுபிடிச்சிங்க. இப்போ ஐடென்டிஃபை பண்ணதுக்கப்புறம் finally there is an effect. What is the effect? Effect is nothing but the final problem what you are going to solve. Like final problem na வந்துட்டு என்னாச்சு, see in speaking in with the 11th proper, after mixing a compound you are going to check your rheological properties, right? If you are going to check rheological property in a particular compound like NBR, nityl compound, if you are going to check. So only thing is usually the TS2 value will be as per the requirement of the compound, right? And you will be monitoring all those rheological parameters up to T90, right? So when you face some difference, like the T90's standard requirement is so much minute, but it is not happening in this process means, அப்போ என்ன பண்ணுவீங்க, you have to write the problem as an effect. இதுதான் என்னோட effect. ஃபைனலாக. அப்போ அந்த எஃபெக்ட்டுக்கு இந்த எல்லா காசஸும் வந்து எந்த இதில் வந்து கான்ட்ரிபியூட் பண்ணுது, அதில் யூ ஹேவ் டு பிரெயின் ஸ்டார்ம் டுகெதர் ஆஸ் அ டீம் அண்ட் யூ ஹேவ் டு கன்வெர்ட் இட் இன் டு ப்ராபபிள் காசஸ் அண்ட் ஃபைண்ட் த ரூட் காஸ், அனலைஸ் இட், take action, check whether you have any side effects, and you have to standardize the actions, then finally get to a conclusion. That's what I told in this 7-step QC story. இதெல்லாமே நீங்கள் tools, you can use all those tools in your QC story that if it is possible I can explain in future. The one thing is that I told is cause and effect diagram. இப்போ முன்னாடி பார்த்தீங்க இல்லையா, அது வந்து cause and effect diagram. அதுக்கு இன்னொரு பேர் இருக்குது, that is fish bone diagram. It looks like a fish bone, right? So that is a fish bone diagram or cause and effect diagram. This once again a typical Kaizen, as I told the suggestion. Sorry, the image is corrected. So this is Kaizen. There, the final product is being packed, right? It is packed and it is ready for dispatch, right? Appo enachna when we have received a complaint from the customer, right? So என்ன சொன்னாங்க complaint customer, சார் நீங்கள் கொடுக்கும்போது வந்து உங்கள் ரப்பர் காம்பனண்ட்டு எனக்கு ஆஸ் பர் த ரெக்குவயர்மெண்ட் வரல, என்னாச்சுன்னா இட்ஸ் காட் டேமேஜ், அதாவது நெளிஞ்சு போன மாதிரி இருந்துச்சு. Here with the robust quality systems and processes, it is not possible at any cost inside the shop floor for creating a bad quality product before sending it to the customer with all those systems for, right? அப்படி இருக்கும்போது in this area we are surprised, like எப்படி இந்த மாதிரி நம்ம டேமேஜ் அப்படின்னு பார்க்கும்போது what we identified is before sending it to the customer place, they are using some labor to carry it in a two-wheeler. Actually, that is the real thing we have identified. Two-wheeler வந்துட்டு இந்த ஒரு பாக்ஸஸை கொண்டு போகிறாங்க, லைக் ஸ்மால் கஸ்டமர்ஸ். அப்போ கொண்டு போகும்போது that box has been popped up, that packing case is corrugated box. So that has been fell down and the corners have been damaged. அதாவது corners இங்கே இந்த corners எல்லாம் டேமேஜ் ஆயிடுது. அப்போ based on this QC story methodology and we have identified each and every stage and we finally came to know that these four parts these four rubber components have been damaged. Appo we have done this small improvement where we have kept a 6-ply corrugated L angle, so as we are ensuring that even the customer is doing mistake, we have done something in-house so as still there is no mistake in our product quality. But because of customer handling, customer complaint, we have done thing, we have given priority to the customer and we have added up cost and we are packing all the products by this L angles at the product. So this is one thing, because then only you will get the order, then give a proper solution to the customer, right? Customer வந்து தப்பு பண்ணாலும் செய்வாங்க, but still நம்ம வந்துட்டு we should have to find out the solution, right? இது வந்து it is only some 2 or 3 more slides. This is an important thing for you. Think about it is visible. இது என்னன்னு பார்த்தீங்கன்னா வந்து PFMEA. PFMEA potential failure mode and தெரியுமா உங்களுக்கு PFMEA என்னன்னு தெரியுமா? தெரிஞ்சுக்கணும், ஷேக்ஸ்பியர் சொல்லியிருப்பார் உங்களுக்கு. Potential failure mode and effect analysis, right? These are all the basic requirements for a shop floor engineer as a rubber technologist. You should know how we are going to find out the issues in the process. These are all the old systems which are being followed regularly at shop floor area. For example, here, இங்கே வந்துட்டு என்ன பண்ணுவாங்கன்னா, there is a process function requirement. We can see mixing ல வந்து requirement of the mixing is to achieve the intended batch quality, right? இதில் what is a potential failure mode என்ன நடந்திருக்கலாம் அப்படின்னா, there is a variation in rheological characteristics, இல்லைனா உங்களோட viscosity மாறி இருக்கலாம், உங்களோட physical or chemical mechanical properties மாறி. So these are all the potential failure mode in your mixing batch, right? So this is the effects of இதெல்லாம் failure mode, இதெல்லாம் effects. அப்போ எஃபெக்ட்ஸ்னால் என்ன ஆகும், முதல்ல நீங்கள் தப்பாக இந்த மாதிரி பண்ணியிருந்தா உங்களோட ப்ராடக்ட் வந்து பெர்ஃபார்மன்ஸ் வந்து சரியாக இருக்காது. It will be deteriorated over a period of time at your application, so that your service life will be deteriorated. அது அப்போது இந்த பொட்டென்ஷியல் எஃபெக்ட்டுக்கு என்னென்னலாம் காசஸாக இருக்கலாம் அப்படிங்கிறது we have to tabulate here. அந்த டேபுலேஷனுக்கு there is a 3 category for identifying the severity, right? அப்போ என்ன சொல்லுவாங்கன்னா, here there will be some particular terms to be followed for, there will be a numbering system like starting from 1 to 10. இப்போ என்னோட ப்ராப்ளம் வந்துட்டு ரொம்ப சிவியராக இருக்குது அப்படின்னா there will be, I have marked it as 7. I have given a 7 score, so as the problem looks a little severe, so as to be addressed immediately. Right? There are some certain conditions which may be explained in future. and inga vandute there is a potential cause for all this problem, and what are all the இந்த ப்ராப்ளம்க்கு நீங்கள் பொட்டன்ஷியல் காசு எடுத்துருக்கு, அந்த பொட்டன்ஷியல் காசுக்கு எத்தனை தடவை உங்கள் ஷாப்பில் ஒரு அக்கரன்ஸ் ஆயிருக்கு அப்படிங்கிறது யூ ஹேவ் டு கலெக்ட் ஹிஸ்டாரிக்கல் டேட்டா. அப்போது பேஸ்ட் ஆன் த ஹிஸ்டாரிக்கல் டேட்டா வித் த கிவன் கண்டிஷன் யூ ஹேவ் டு கிவ் அ ஸ்கோர் ஃபார் திஸ் ஃப்ரம் பிட்வீன் 1 and 10, ரைட்? அப்போது நெக்ஸ்ட் வி ஆர் கோயிங் ஃபார் ப்ரிவென்ஷன் அண்ட் டிடெக்ஷன் ப்ராசஸ் கண்ட்ரோல்ஸ். அப்போது நீங்கள் என்னென்னா ப்ரிவென்ஷன் மெஷர் வச்சுருக்கீங்க அந்த ப்ராப்ளம் வந்து கரெக்ட் பண்ணுறதுக்கு, தென் வாட் ஆர் ஆல் த டிடெக்ஷன் மெத்தட்ஸ் யூ ஹேவ், இதை பேஸ் பண்ணி you have to give a score for detection. When you multiply all these severity, occurrence and detection, you will get a RPN number, right? So RPN is nothing but a risk priority number, right? Risk priority சொல்லுவோம். அப்போ இந்த A, B and C மூணு multiply பண்ணா you arrive with a value like for the first thing I arrived 168. Usually if it is crossing 100, the number is RPN is crossing 100, you have to give more attention. இதெல்லாம் நான் ஏன் சொல்கிறேன் அப்படின்னா, இது PFMEA is a vast topic. We can take a particular problem and we have to create a PFMEA for it with our team so that the RPN value will be arrived, and based on this RPN definitely you will know what is the priority of the issue and the causes and what we have to do immediately. அதுதான் இந்த இது சொல்கிறது, லைக் என்னன்னா PFMEA சொல்கிறது, ரைட்? So here it is a typical mixing sequence. நீங்கள் போயிருக்கலாம், maybe you would have gone for some implant training or you would have seen, or some may not have been seeing this mixing process. So இதில் வந்து there is a mixing sequence, right? நீங்கள் போன as I showed you Banbury mixer, right? Our Banbury mixer போனால் there will be a mixing sequence, because this sequence will ensure whether the mixing process has been done appropriately based on the standard அப்படின்னு சொல்லுவோம். என்னன்னா here it is keep blower on, keep hopper door closed when not required. Blower வந்து இந்த மெஷினோட blower on பண்ணிக்கிங்க. Why blowerனா வந்துட்டு when you are mixing there are fumes will be created, there will be some fluffy carbons will be using, and many fillers will be using like silica and color compounds also. So in that is the case you have to switch on the blower. இல்லைனா என்ன ஆகும் அப்படின்னா வந்து once again all the contaminations will be falling into the bag. அப்போ அந்த blower வந்து நீங்கள் ஆன் பண்ணணும். அப்புறம் கீப் ஹாப்பர் டோர் க்ளோஸ்ட் when not required, right? ஹாப்பர் டோர் அப்படிங்கிறது as I showed you in the first picture of Banbury, நீங்கள் வந்து காம்பவுண்ட் உள்ள நீங்கள் கெமிக்கல்ஸ் லோட் பண்ணும்போது there is a sequence whenever to open the hopper, when to close the hopper. So அந்த system you have to follow, the sequence you have to follow. Clock, for example my mixing time is 420 seconds, right? 420 seconds then set the clock. 40 RPM, as I told you, there is a rotor, two-wing rotor for example. If there is a two-wing rotor, then the rotor should be rotating at 40 RPM, revolution per minute, right? 40 RPM you have to load your rubber. Maybe this is a typical mixing sequence where they are loading 2/3 of a strained master batch, and along with this all those chemical ingredients to be loaded, and finally we have to lower down the RAM and then start the clock and so on. Upper this thing to be followed at your mixing operation, right? Next 240 seconds வந்து ஆயிடுச்சு. So 240 seconds வரும்போது you have to float the RAM. There are 3 phases of the RAM. One is down, the float RAM, and up phase, right? Float na ஒரு மாதிரி it will be, the RAM will be shaking altogether, right? This is a sequence given to mixing. So in 240 seconds you have to float the RAM, add all those process oils and other chemical, lower down the RAM. You have to adjust the RPM to maintain the temperature at 107 degrees centigrade. நீங்கள் 240 செகண்ட்ஸ் நீங்கள் மிக்ஸ் பண்ணிட்டு இருக்கும்போது என்ன அப்படின்னா வந்து the temperature will come to 99, 100, 102, 103, it will be increasing, right? Because you are increasing your RPM, you are controlling your process, right? You are lowering the RAM, floating the RAM, opening the hopper door, closing it on time. இப்படிலாம் பண்ணும்போது என்ன ஆகும், there is a shear force happening inside the given inside the Banbury chamber so as to increase the temperature, right? So mechanical thing is happening inside. The temperature will rise up to 107. You have to maintain it at 240 seconds sequence. Then finally, either follow பண்ணிட்டு 420 seconds வரும்போது you have to float the RAM, dump the batch at 107. You have to close the door, raise the RAM, and finally don't forget to clean the top of the RAM prior to loading the next batch. அப்போ when you follow this mixing sequence, as well as we have done already batch weighing system, you have weighed it as per the requirement and you have mixed it now. So the compound quality is ensured. This is one thing, right? இது வந்து autonomous maintenance. It is the importance of GSU rules. So as I told in the so many steps I have told, there என்ன சொல்ல வந்தோம் அந்த ஸ்டெப்பில் நிறைய இதில் ஒரு பாயிண்ட் என்ன சொல்லி மை மிஷின் கான்செப்ட்னு சொல்லி. அப்போது இட் இஸ் autonomous maintenance. I will give this is a checklist, a typical checklist of Banbury mixer machine where என்னென்னலாம் பண்ணணும். When நான் என்ன பண்ணணும் இப்போ when daily, weekly, monthly. What are all the activities to be done daily, weekly and monthly you have to monitor, and how there is a pictorial representation of how எப்படி பண்ணணும்ட்டு, and there is a TPM code and when and these are all the checkpoints here. Right, inspection ko, cleaning ko, they have given a checkpoint. Autonomous maintenance is nothing but to say in simple words, when your machine is going to get into a critical breakdown, அப்படின்னா அந்த critical breakdown வரதுக்கு முன்னாடி your machine itself should understand that I am going to stuck up into a critical breakdown and I should get tripped immediately. நான் வந்து அந்த breakdown போகக்கூடாது, நான் இந்த மிஷினை நானே ஆஃப் பண்ணிக்கணும் அப்படிங்கிற மாதிரி இருந்துச்சு அப்படின்னா, that is a basic example of autonomous maintenance, and we have to think of how we are going to do the autonomic maintenance in the shop floor. Right? This is a typical rubber processing shop floor where this is your shop floor, and these are all the this is the organization structure where this unit level head, this department section in charge, these are all the people who are going to follow different zones and why they are inside. இதெல்லாம் இருக்கும். இதெல்லாமே இந்த tabular column there will be a number of zones and machines and what are all the machines. The typical shop floor layout will be like this one. இது வந்து ட்ரபிள் ஷூட்டிங் எக்ஸாம்பிள். ஒரு மோல்டில் வந்துட்டு ஆக்சுவலாக வந்துட்டு இட் இஸ் அ ஓரிங் மோல்டு வேறு த ப்ராப்ளம் இஸ் லைக் இது வந்து ஸ்மால் ட்ரபிள் ஷூட்டிங், டே டு டே ட்ரபிள் ஷூட்டிங். என்ன பண்ணுறாங்கன்னா தேர் இஸ் அ ஃப்ளாஷ் அக்குமுலேஷன் வந்து ஜாஸ்தி ஆகுது. அப்போ ஜாஸ்தி ஆகும்போது அதோட கிளீனிங் டைம் வந்து மோல்டு கிளீனிங் டைம் இஸ் மோர் தென் த க்யூரிங் டைம். ஸோ வாட் தே ஹவ் டன், தே ஹவ் ரெடியூஸ் த ஸ்லக் வால்யூம் and then the cleaning after curing they have found that this has been reduced and that process parameters identified has been included in the process sheet, right? So as I told, right, this is like a customer perspective is quality, right? Adavadhu as I already told, when your customer is coming in, when your customer is coming in, they will expect the transformation which you have done at your process, and that transformation in the process and your people transformation will reflect your product's quality. Appo the perspective should be in such a way that this is your final inspection gate where you have displayed so many things here, the defective samples la ipdi irukum. So idu வந்து inspection பண்ணும்போது ஒரு inspector should be very aware about the defective samples and inspect accordingly ன்னு சொல்றதுக்காக இந்த மாதிரி it has been done in the company, right? So இது எல்லாத்தையுமே we have to keep in mind and work in a process. Finally வந்து machine condition monitoring என்ன சொல்றாங்கன்னா, this is extruder and here in this extruder when extrusion is happening there will be some air pockets, right? So if air pockets, if it is coming because of the mixing is not done properly, the gases while mixing are not evaporated, not degassing is not done properly, that will be included in the product's quality. அதாவது air pockets ஓட உங்களுடைய ப்ராடக்ட் வெளியே வரும். ஸோ அப்படி இருக்கும்போது this is a main unit where this called as vacuum pump, where it will be maintaining a vacuum in the extruder machine. So as when this is set in a particular specification, then definitely that entrapped air will be coming. Correct. So அந்த மாதிரி இருக்கும்போது you have to monitor this vacuum pressure continuously. And here, see, this is extruder chilled water line, right? In the chilled water line, there is a spec for maintaining the temperature of the chilled water. அப்போ then the water should be contaminant free. Like இப்போ நீங்கள் chilled waterன்னு போனீங்க அப்படின்னா எப்போ contamination வரும், இல்லை the pipeline இருக்க the corrosions will happen and finally your water will get contaminated before getting into the TCU. TCU is nothing but temperature control unit. When it is entering into the TCU, it will not function properly and temperature variation will be there, right? So in that case the water quality is deteriorated and the functioning of TCU will be improper, deviating the process. That is good. And finally I will end up with this low cost automation principle for a better understanding. As I told, this is the dump mill and this is the chute where the mixed rubber compound will be dumped on this two roll mill and the operator is mixing and sheeting out, right? So this is the work is done here. இப்போ என்ன ஆயிருக்குன்னா, இதுதான் வந்து shoot. அப்போ இங்க dump பண்ணும்போது the total mixed batch will be dumped here and the batch will be spreading here and there. அதாவது கொஞ்சம் ஹைட்ல இருக்குது இல்லையா, கிட்டத்தட்ட டிஸ்டன்ஸ் பார்த்தீங்கன்னா ஆல்மோஸ்ட் சம் 500 mm இருக்கும். முன்னாடி வந்து ஒரு 500 mm இருக்கும். பட் now what we have done is we have done this கைசா, இந்த மாதிரி ஒரு சின்ன சிலிண்டர் அரேஞ்ச்மெண்ட் போட்டு we have fabricated this sheet and enclosed it. என்ன பண்ணியிருக்கோம் அப்படின்னா, when the drop door of the Banbury is open, அதை ஓப்பன் பண்ணும்போது என்னவோ this cylinder will activate and this unit will come down, ensuring that there will not be a much of wastages while the mixing process. So this is one thing I would like to share in the low cost automation. Just வந்து ஒரு ஓவராலாக I've given a comparison about total quality management and what is the importance of quality to be followed by a shop floor person. Because as a rubber technologist, we should focus on complete processes. We should understand the processes. Then only we will be able to give a high quality product. So this is the main thing I would like to share in this overall presentation. And this is what a TQM approach is. Thank you everyone for giving this opportunity. And let us go for some queries.
So,
am I audible?
yes, Senthil, so this is the time for questions. So students, anyone having a questions, please you ask your question or feedback. I think Senthil, the students are heading to another class as 10:30. They are having a class.
Fine. Okay.
So they will write questions through mail or chat, right? So you will
Alright,
answer
okay, fine.
some
Alright.
doubts, right?
Chat and see, finally, this is one thing I would like to say. This is nothing but this is an overall picture of what is TQM. There are so many things to be done in TQM. And இதில் வந்துட்டு உங்களுக்கு புரிஞ்சிருந்தாலோ புரியாட்டியோ, you can speak with your professor Sheikh and you can write up a mail to me, and he is having my contact number as well as my email ID also, right? So anything else, Mr. Sheikh?
Yes, this juncture I would thank to Mr. Senthilkumar for a great lecture. He is touch upon TQM definition, steps to implement TQM. Right? Then we learned newly, that is VSOP, OPL, SCADA system, then 5 sensors, then FMEA. Students are in the beginning stage of total quality management. They doesn't know what is FMEA, right? So there are lot of new things we learned this lecture. So on behalf of Department of Rubber and Plastic Technology, HOD and faculty members, we thank your sincere effort and shared your knowledge to us. So thank you very much, Mr. Senthil.
Thank you, Sheikh. Actually, once again I am repeating this because as we told, it is a TQM approach. I wanted to cover almost all the things what is included in the TQM. This is the main objective of the session. But definitely in future, if there is an opportunity, I can explain more about each individual topic.
Okay, we'll plan one more sessions, right?
Yeah, thank you so much. Thank you, students. If I get some few feedbacks, will be good for me.
So students, please anyone give your feedback. Okay.
Any one or two?
I'll collect. I think they are
Right,
went
okay,
to the
fine.
classes,
Okay then.
right? So I'll
Thank you,
collect
thank you.
and share.
Thank you, Sheikh. No issues. Thank you so much.
Thank you.
For the opportunity.